This video is solving systems of linear equations. I'm going to be focusing on the elimination method, which is again an algebraic way of solving a system of linear equations. First thing I'm going to do is write out the steps that we have to follow. For elimination, the first step is to multiply each equation by a suitable number so that the two equations will have a variable, so the same variable, so both of them will have the x or both of them with the y, a variable with the same coefficient. That means that they will both have the same number in front of the x or the same number in front of the y. Step 2 will be to subtract the equations. Now you can actually combine step 1 and step 2 by when you are multiplying by a suitable number, you want one of the variables to have a positive coefficient and the other variable to have a negative coefficient, because then that will automatically subtract them as they are, and then you can just combine the two equations as you see them. So once you have that, once you have subtracted the two equations or combined the two equations the way they're supposed to be, you will then solve for the variable. This means that you will have one variable left because you are eliminating one of the variables. Once you have solved for this variable, whichever one you're solving for, you will then plug that back in and solve for the second variable, just like you would for substitution. So if we look at this first example, we want to look, again, I'm going to try and put step 1 and step 2 together. We look at our variables, x's and our y's. We look to see if we already have the same coefficient on either the x or the y, because that'll make it much easier. So on the x's, we do not have the same coefficients, but on the y's we do. They both have a 4, but I can go ahead and put together step 2 by making sure that my coefficient is one of them is positive and one of them is negative. That means that step 1 and step 2 are actually done. We just need to combine these as we see them. So that means that because 4y minus 4y will be 0. That will eliminate. So I can combine these as they are. What that means is this is a negative 7x and a positive 4x. I want to combine these as they are. So that will become a negative 3x. Positive 4y and a negative 4y will become 0. So these will eliminate. And this will be equal. I have a positive 24 and a positive 0, which is just a 24. I then solve for the variable of x, because that's the only one we have left. I divide by negative 3, and I will have x is equal to negative 8. Now that we have the x variable, we can then plug this back into one of the originals and solve for the second variable. It does not matter which one you plug it in for, just like with substitution. You can plug it into the first or the second one. I will plug it into the second one only because of the numbers and because it's equal to 0 right now, so it'll be a little bit easier to add and subtract. So I will plug in to the second one. I'm going to have my 4, but then I have an x, and I know what x is, so I put parentheses. I plug in that negative 8, close parentheses, minus 4y is equal to 0. I simplify, so I have negative 32 minus 4y is equal to 0. I want to add the 32 to the other side, so I'll have negative 4y is equal to a positive 32. And then I'm going to divide by negative 4. So y will equal to that negative 8 as well. So now that we have the x and the y, we can write our answer as a coordinate of x is negative 8 and y is negative 8. That is our solution. This is where the two lines will intersect. -8, -8. On our second example of elimination, again, we look to see if we already have a variable that has the exact same coefficients. So the x's do not have the same coefficients, and the y's do not have the same coefficients. So that means we need to multiply each equation by a suitable number so that the two equations will have a variable with the same coefficient. Sometimes if you have a variable that has a number, a coefficient, and then the second variable has a 1 in front of it, you only have to multiply one of the equations. But this example, because we have the variable has two different coefficients on either one of these, we will have to multiply both equations by something. Now, you can go ahead and see that for step 2, the subtract the equations. If you look at your x's, one of them is already positive, one of them is already negative. The same with your y's. One is positive, one is negative. So that means that you will already be able to subtract the equations. You will already be able to do step 2. So we need to find a suitable number to multiply each equation by. And it really depends on what you want to eliminate. Last time I eliminated the y's, I can try and do the same thing here. So in order to eliminate the variable when they have two different coefficients, you actually multiply the equation by the other coefficient. So this top equation has a 7 on the y. The other one has a 2. That's what I want to multiply that top equation by the 2. So I multiply the top equation by the 2, and I'll multiply the bottom equation by the 7. Because 2 times 7 and 7 times 2 will give you the same value. So I have to make sure I distribute these values to everything in that equation. The same thing with the 7. I have to make sure I multiply or distribute that value to everything. So the top equation will become negative 14x plus 14y equals negative 42. The second equation will become a positive 28x minus a 14y will equal to a positive 154. Again, you multiply the equation by the other coefficient to get them to be the same. Now we're going to subtract the equations because, and like I said, we're just going to combine them as they are. The main reason is because one of the coefficients was already positive and one was negative. I could have done the same thing to eliminate the x's. I would have multiplied the top one by the 4 and the bottom one by the 7. So let's combine these as they are. So I have a negative 14x and a positive 28x. So I'm just going to combine those as they are. That's going to give me a positive 14x. The positive 14y and negative 14y will eliminate. We'll have it equal to, we have a negative 42 and a positive 154. If I combine those, we will get 112. And then we're going to solve by dividing by 14. 112 divided by 14 is x is equal to 8. And no, not all x values will be equal to 8. This just happened to be, we had negative 8 on the last one. This is just a coincidence that we have a lot of 8s. So again, we solve for the variable. Now we need to solve for the second variable. I plug it into either one of the original equations, and then I solve for the other variable. I will probably plug it into the second equation because that's at positive 4. So I have 4, then I have my x value, so parentheses 8 minus 2y is equal to 22. So I have 4 times 8 is 32. So I have 32 minus 2y is equal to 22. If I solve for this, I'm going to subtract the 32, so I get a negative 10. Then I have to divide by a negative 2. So negative 10 divided by negative 2 is a positive 5. So y is equal to positive 5. So our solution for this problem, the x was 8, comma, the y was 5. Our solution is 8, 5. Please remember that a solution to a system is written as a coordinate every single time. This is solving linear equations, systems of linear equations, by elimination.